Hi, thanks for joining me. This is the first video of quite a few in which I'm going to go over solutions to the current Invariants Maths Summer Competition. If you don't know what that is, I'll leave a link in the description below. The Invariants is the Maths Society at Oxford, and they're currently running a competition where every week through summer they put out 3 different questions, and the top 3 people at the end of summer who've got the most answered correctly will win some cool prizes. You don't have to be an Oxford University student or even studying maths, you just have to be a university student, but I'll leave all the details in a link below. And it's not too late to enter if you haven't already. Anyway, this is the first problem from the first week, and if you missed the first round, I'll leave the question in the description below as well, but I'll quickly describe it now. We have n frogs, which here I've denoted with these circles, and at each second, at the ith second, the ith frog will eat one of the frogs smaller than it with probability 1 over n for each frog independently, and there's a chance that it might not eat any frogs. So for example, if we get to the second frog, so after 2 seconds and the first frog is still alive, well then it eats this frog here with probability 1 over n, and it eats no frogs then with probability 1 minus 1 over n. And we want to know what is the proportion of frogs left as n goes to infinity. Okay, so if you didn't have a go at the problem, I want to now, pause the video now, but I'm going to go over a solution. Okay, so the first thing to do is look at an arbitrary frog, say the ith frog. Now the only way the ith frog is going to die, or get eaten, is if one of the frogs of greater size eats it. Okay, so that means it's one of these frogs, and there are precisely n minus I of these frogs. Now if we take any one of these n minus I frogs, it eats this frog here with probability 1 over n. And thus, the ith frog surviving getting eaten by any particular frog is 1 minus 1 over n. But because of independence and the fact that there are n minus I frogs here, the probability that ith frog survives, that's going to be 1 minus 1 over n, because that's the probability it survives one of these particular frogs eating it. And because there are n minus I of them, and because of independence, it's that thing there. Now we're concerned with the proportion of frogs, but firstly let's work out the number of frogs there are left, or at least the expected number of frogs we have left. So the expected number of frogs left is simply the sum of this over all the possible i's. So the expected number of frogs left, so the sum from I equals 1 to n of this thing here, and let me just explain why that's the case. The number of frogs left is simply, we go down this list of n frogs here, and we add 1 every time that there's a frog. And obviously we have to consider weighting it by the probability that that frog is alive, so we're simply doing the sum. You can think of it as like 1 times, and then that's the probability that the ith frog is alive. Okay, so we want to evaluate this sum here, and that this is just a lot of algebra, knowing geometric progressions and things like that, but I'll do that in just a second. But we want to know the proportion. This is going to be the number of frogs left, so we've got to calculate this, and then afterwards divide by n, and then take the limit as n goes to infinity. Okay, and then that's essentially the problem done, but let's go through the work and work out what this sum is here, then I'll divide by n, and then take the limit as n goes to infinity. So we've got the sum from I equals 1 to n of 1 minus 1 over n to the power of n minus I, and we want to work out what that is explicitly. Okay, first things first, I can write this as the product of 1 minus 1 over n to the power of n, and then times by 1 minus 1 over n to the power of minus I. So this thing here is equal to the sum from I equals 1 to n of 1 minus 1 over n to the power of n times 1 minus 1 over n to the power of minus I. Okay, cool. But I'm going to rewrite this thing here as n minus 1 over n. Okay, and the same thing here, I'll write this as n minus 1 over n. But because we're raising it to the power of minus I can flip this fraction and replace the minus I with just I. Okay, cool. And now this thing here is independent of I, so I can bring it into the front of the summation. So this is n minus 1 over n times the sum from I equals 1 to n of n over n minus 1 to the power of I. Okay, cool. Let's quickly go over geometric series. So suppose we have S equals r plus r squared plus dot 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 plus r to the n. Obviously in our case here we've got this sum here, and r would therefore be n over n minus 1. Well then let's multiply through by rs. This is very standard. So then the r multiplied through to give us r squared will multiply to give multiplied r squared by r will give us r cubed, and so on. R to the n minus 1 times r will give us an r to the n, and then r to the n times r will give us r to the n plus 1. I look at the difference of these two lines, so here I get s 1 minus r by factoring out an s, and on the right hand side I'll get an r, then this will cancel with this, all the middle terms will cancel, and I'm just left with r minus r to the n plus 1. Dividing both sides by 1 minus r gives me this thing here. Okay, cool. Going back to this thing here, we have that r is n over n minus 1, so just plugging it straight into that formula there, we get, let's drop this down, oh I forgot, to the power of n there, n minus 1 over n, raised to the power of n, times by this thing here, which we showed is this thing here, so that's n over n minus 1, minus n over n minus 1, to the power of n plus 1, divided by 1 minus n over n minus 1. Now, multiplying the top and bottom of this fraction here by n minus 1 will give us n minus 1 over n to the power of n. This thing here becomes n. This thing here becomes n times n over n minus 1 to the power of n. Okay, by taking out a factor of n divided by n minus 1, and then the n minus 1, which we're multiplying the top by, will cancel. Then on the denominator we get an n minus 1 here, minus an n, obviously the n's cancel, and I've just got minus 1 on the denominator, which is the same as timesing the top by minus 1. So we'll just write it as, the numerator is minus n plus this thing here. Okay, cool. Now let's just bring this inside the brackets. So this thing here will cancel really nicely with this thing here, because that's the reciprocal of that. So we're left with n minus 1 over n to the power of n times minus n plus n. And perhaps we'll take out the n. So we're left with this thing here. Okay, cool. So this, as we showed before, we've just taken this and done some tricks to it to get it into a more explicit form. And this is the expected number of frogs that we have left. We don't want to know the expected number of frogs, we want to know the proportion of frogs. So we have to divide this expression by n, which is quite nice because we've got an n out the front, so that will cancel nicely. So the proportion of frogs, therefore, we'll call p. Obviously will be a function of n, but in particular it's going to be 1, don't need the brackets, 1 minus n minus 1 over n, all raised to the power of n. Okay, and we want to know the limit is n goes to infinity of this expression here, and we can just rewrite this thing here as 1 minus 1 over n, and this is a very standard limit, so let's work it out. The limit as n goes to infinity of both sides, that's the limit as n goes to infinity of the right hand side. Okay, and basic tricks about limits, algebra of limits, I can write this as the sum of two limits, so this is 1 minus the limit as n goes to infinity of 1 minus 1 over n to the power of n, and this is a standard limit, that's 1 over e, so that's 1 minus 1 over e, and that's our answer. Yeah, so this problem I feel wasn't too bad once you had the starting point, once you understood how to get the summation, and then after that it was just basic algebra, knowing geometric progressions and whatnot, and then getting to this line here, and then of course you need to know your standard limits. But I think the hardest part of this problem was just getting to that first line, understanding how to make an algebraic expression out of the problem. Anyway, that's the end of this video. In the next video I'll go over part 2 of this problem. If you did enjoy my solution, please like and subscribe. Check out my other videos as well. Anyway, for now, have a great day. See ya.